So this is a quick run through in terms of DIATOMIC. It's a project that's been running for a couple of years, digital twin for Birmingham. And the view today is to look at challenges for data past and present. The project was led by the Connected Places Catapult. It was an interdisciplinary cross-cutting framework, and it was an innovation capability project. It was looking to drive growth and prosperity locally and enhance the reputation of West Midlands, not just regionally, but also globally as well. There's been a bunch of different things with Ulsan in South Korea as a country as well. One of the work packages, it was quite a wide project overall, but one of the work packages was looking at digital twin development. And this was as a demonstrator across 3 geographical areas with distinct focus themes, quite actually different focus themes. And the reason for that was, I think in part to look at potential use cases as being different effectively, to see how a platform might help to allow that to be more interoperable. Talk today will focus on a quick demonstration, and we'll maybe come back to that in terms of interactive mapping and data viz from the University of Birmingham's use case. But 2 main points we'll come back to after the demonstration in terms of accelerating innovation, particularly for SMEs, and that is openly available unique IDs. Identifiers are a foundation for smart city digital twins, and also focus on improving pain points of data governance frameworks. And that will surface more data more quickly to more users who can potentially add value. In a moment, there will be, we'll maybe put a pin in that in terms of a quick demonstration, but I'll come to that in a moment. The first overview of the structure. So we decided to use Docker containers using a sort of Python first, JavaScript for the front end, but look at open source tooling where possible. So we've lifted and shifted containers. It was developed sort of locally within platforms on-prem in terms of the University of Birmingham, and then we took that over to the Azure platform as orchestrated using Kubernetes. So there's 4 containers, data pipeline container, and we found using Prefect IO was really helpful with that. Database, which is using Postgres, and data viz container is JavaScript, just using open source tooling, and also an API container as well. So effectively, these particularly sort of talk to each other through APIs. The aim was to develop data pipelines, blend different types of data sources, such as geography, categorical, time series, and different granularity. Didn't get to advance the second point quite as much as we had hoped, and that's research techniques for predictive analytics in the energy and built environment space at a hyper-local level, is really to push that down into a very, very localized level. And the third one, to create interactive viz tools to help drive public engagement of the energy transition. This would be the place I would go, but in time-honored fashion of live demonstrations, there's actually a problem with the website at the moment. I suspect somebody is working on it, unfortunately, so it's not actually going to show what I want it to show at this particular point in time. But this particular DIATOMIC UK website, people do go there over time, that will work effectively. Platform still under development phase, clearly today as well, but Kubernetes orchestration allows the platform to be shut down and restarted overnight. So we've just been doing that effectively to save money from a sort of 12 hours to 12 hours on and off. And that shows flexibility of using Docker containers for the platform and an orchestration, depending on what you want and depending on what you're doing. You know, you can potentially take it across to, we use Azure, but you could use AWS, you could use Google Cloud as well. So it's really quite a flexible issue from that perspective. The containerized development seems to be a flexible way of development, with API calls sharing data internally between containers and externally. We did have some pivots during the project, mostly due to greater availability or a lack of availability of data. So for example, building data was available at scale. We were originally looking at an area of East Birmingham, but decided to flex that up to the whole of West Midlands Combined Authority area. Whereas electrical system monitored data is found to be of limited coverage at secondary substation level. So again, we sort of pivoted up to grid supply points on that, which cover a much, much bigger geographical area. There's a whole bunch of interesting ongoing research areas in developing synthetic data to help fill in data gaps. Back to this issue around unique IDs and a foundation for smart city digital twins. They will have a cost associated with effective curation, but I guess the question is for different levels of government is how best to pay for these. You know, examples are unique property reference numbers, building footprints, building volumes, energy system assets, road junctions, the list goes on and on. You know, so regardless of the added value, such as accurate spatial data, which could be, you know, kept in terms of paid or larger amounts of sort of licensing around it, the unique IDs themselves, we believe, should have less restrictions, so that, you know, basically if people know what they're talking about and linking other data to, then everybody's on the same page. Data access and governance, particularly for SMEs, can chill innovation, stop it altogether. Just costs are too large. So reducing the burden for appropriate trusted data access for both users and data providers is a fundamental driver for innovation. And that should increase, not decrease, trust and be fine-grained enough to provide flexibility across different use cases. So trusted system data sharing and licensing without the requirement for legal team input for each data set, that's felt to allow data owners greater market reach to valorize their data, and also innovative organizations to add value to that data too. So the future where data access and governance is helping to promote innovation rather than hindering it, that would be very helpful. I'm going to wrap up there because I think in terms of timing, none of this would be possible without colleagues, name check there, Zoya, Keris, Tom, Adrian and Jake, also the team at Siemens and the teams at Birmingham City University and Aston Universities too.
Grant, question for yourself. You mentioned looking into the generation of synthetic data. From experience, this sounds easier than it turns out to be, particularly when representative data is sparse or not available. How are you addressing this?
So that's a really good point. Is I think in the broadest sense is to try and work with data owners who do have quite an interesting amount of coverage of whatever it is that they're looking at, and then to work with them to basically obfuscate or, you know, provide a degree of non-disclosure effectively. So take it up to a certain size or aggregate it over particular areas. But it's an ongoing challenge. Is how do you make things, keep things private in some sense, non-disclosive, but actually try and keep the representation of whatever it is the data set you're trying to look at, for example. But broadly speaking, it's using as much real data or actual data as possible, which is proprietary, but trying to then obfuscate that to a certain level. So it's using real data rather than trying to maybe synthesize too much, if that makes sense.